Okay, came up to Urslan because I know you guys missed the table. This video is actually for Claire Weber, who has some sarcastic remarks about the table every single day of her life. My voice, I don't have the virus. It's probably going to go in and out today. I'm also going to do the dissection for next week. But I wanted to run through, some of you said on the survey that I posted on Teams that you wanted another resource, considering that the test is going to be 40 to 50% on blood flow, that you wanted another resource outside of just the audio where I kind of list the steps. And so I am going to include some things on here today. Just take notes, take a note. I'm going to walk through as many things as I can think of and kind of intertwine it into one cohesive lesson. Okay, so the first thing, you have the entire cardiovascular, the circulatory system with both the veins, which are blue, and the arteries, which are red, except for the pulmonary arteries and veins, which I talked about on, you probably saw in the packet and on the audio. And we'll get to those in a second. I'm in essence going to run through blood flow throughout the entire body, but focusing on the heart for sure. We're first going to start with the intrinsic conduction system, which a question on the test is going to be about what that means. And if you remember back to the audio, it means that your brain is not sending a signal every single second of the day. That your pacemaker, which is going to be in the right atrium, right here, and it is going to generate a depolarization signal that is going to start the heartbeat moving diagonally across the heart. So I cross-section the heart here. You may or may not be able to see it, which is not critical to this, but it's going to start in the right atrium. So the SA node is in the right atrium. It's going to send diagonally to the AV node, which is going to be in that interventricular septum, which you'll see in the dissection today. And then it's going to go to the AV bundle, which is right smack dab in the middle of that septum. And then the bundle branches right here. And then the Purkinje fibers are going to branch across the heart. What I'm telling you is that this is how the heart actually expands and contracts. It is a muscle pumping blood to the rest of the body. So that is how we actually generate a depolarization signal diagonally across the entire heart. You can notice that the apex is pointing down towards the left. You have to reorient yourself in this, and you'll have to do that again with the dissection, because this is going to be on your right hand side when you're watching the video, but remember it's in the patient, so this is the left hand side. Okay, so we're going to walk through blood flow, the entire thing, with some offshoots and reminders of other things that are applicable to the test. You can start anywhere on the test. It is going to be an essay question. Here's your second essay question. I mentioned the first in the EKG lab. Here's your second on blood flow. But I can tell you there are a lot more multiple choice questions on this particular test that deal with, okay, blood is now in the left ventricle. What chamber did it just come from? What valve did it just move through? And so really knowing, it's just a way of asking a question in a little bit different of a way. So my point being that you can start blood flow from anywhere you want. Since it's a cycle constantly moving through, when we get to the kidneys, before the cat, we'll talk about how your kidneys see blood, the same blood, every minute to a minute and a half. So that's about the time it takes to rotate or circulate, is a better term, throughout your entire body. So we're going to start though in the left atrium, which is going to be up here. So I think it's easiest to start there. Excuse me, it's where oxygenated blood is going to originate back from those pulmonary veins, and specifically back from the lungs, which you can see these purples right here are going to be some of the bronchioles moving into the lungs. But I only have the cardiovascular system present on this particular scan. Okay, so left atrium, it's going to move inferiorly through either the mitral valve Most doctors call it the mitral valve or the bicuspid valve. Remember, the bicuspid valve is going to have two valves that act like doors, that when enough blood is pooled in the left atrium, it will start to push on those doors, and then they'll slam shut behind each of the particular chambers so that you don't get a backflow of blood. This needs to circulate again throughout the entire body in a systematic fashion. And because of that, you can't have backflow. If you do, that's going to be that murmur sound. Okay, so left atrium to the left ventricle. You can abbreviate on the test anytime you want. You do not need to know the actual names. So LA to LV. And then it's going to move up through this aortic semilunar valve into the aorta. One important note is that as it moves through that thick artery off the top, moving this direction, it is the thickest artery in the body. Blood pressure is higher in the aorta than anywhere else in the entire body because of the magnitude of force coming from that left ventricle. That is the initiation point for blood flow throughout the entire body. And because of that, blood pressure is going to be extremely high. So you don't want any sort of burst or clogging in that aorta because it is the first stop post-heart to the entire body. One important thing is, yes, we do have this aortic arch, which there are going to be coronary arteries sticking off the top of it, but we also have a descending aorta moving down this direction, so that the ascending aorta coming off the top is going to service the entire superior part of the body, be it the brachiocephalic artery, the common carotid artery going up through your neck by your throat all the way to the brain, or the subclavian artery. I would know those arteries. I'll kind of address that in the packet as well. You can remember BCS, like the BCS National Championship. So there are 3 arteries coming off the top. Again, this guy, you can look in your packet as well, the brachiocephalic artery, the C word, common carotid, going up through the neck, and then the subclavian is going to go off to the left part of the arm. And there are 3 arteries, which I'll show you when we get to the heart dissection, coming off the top of the heart. But then again, there's a descending aorta that all of your arteries are going to move off of below the heart, on the inferior portion of the body below the heart. And so it'll go all the way to your groin region, and then it'll branch off into the iliac, which are like the groin, where they divide into the 2 legs. And those will proceed all the way down to the lower extremities, whereas these brachiocephalic and subclavian are going to go all the way to the sides or the inferior portions of your distal is a better word, distal portions of your arms. Okay, so now we are back. We're done with the oxygenated blood. Blood will be exchanged with the capillaries, which aren't pictured here. They would be purple. They're purple because you have a mixture of oxygenated, deoxygenated blood. Those capillaries are 1 cell layer thick. On the test, remember their exchange of blood between oxygenated and deoxygenated. And now we're back to the veins. And so the veins are going to be represented by blue. One important note, here, let me get off of this for a second. If you notice this particular, that particular vein right there is the femoral. But then going down the posterior part of the leg, 2 that are easily confused, that if we're back for the CAP practical, you need to differentiate between. The saphenous vein is going to go down the posterior part of your leg in your hamstring region, versus the femoral is going to be going down the anterior part of your leg into the quad region. Okay, get my pen back here. So we're moving back up from the distal part of the leg, going back through the iliacs, but now we are going to progress into the inferior vena cava. All of your veins from the inferior portion or the distal portion of your body are going to drop deoxygenated blue blood into the inferior vena cava. Same thing is going to happen with the superior portion of the body is going to drop into the superior vena cava. Those are going to take deoxygenated blood back into, now we're on the right side of the heart, is going to be the right atrium. Moving from there, you are going to move through the tricuspid valve. It's more or less the same thing as the bicuspid valve, except for the fact that it has three distinct valve portions to it. As you return to the heart, blood pressure is almost zero. You can refer back to the mechanisms that veins have, whether it be the squeezing of the skeletal muscle or those individual valves that shut off after blood moves through the veins. Because blood pressure is almost zero, it's circulated down throughout the entire body. Now it's fighting gravity up, against gravity through the arms and the legs, and blood pressure is almost zero. So that blood in the right atrium is going to put pressure on the valves, the tricuspid valve, which has three flaps, and then you'll move into the RV, which is the right ventricle. The right ventricle then is going to move blood into a red structure. Do not get confused by this. Remember, the arteries move blood away from the heart. Yes, they are red most of the time, almost all of the time, except for this case. But this case does not violate that law, in that it's still moving blood away from the heart, away from the right side of the heart. So the right ventricle is going to move blood through the pulmonary semilunar valve, which you'll see on the dissection, up off the top of the heart through the pulmonary arteries. It's going to go to the lungs again right here, and the lungs are going to reoxygenate the blood with alveoli. And then what's going to happen is, which you can't see right here because blood is actually, you can see on the posterior side right here that blood is going to return to the heart in the form of oxygenated blood, and it's going to be through the through the pulmonary veins. And pulmonary veins are going to bring reoxygenated blood from the lungs back to the left atrium. So I'm going to walk through this once more. I know the coloration, you might have to enlarge the screen, but this is important so many times over on the test. Left atrium through the bicuspid or the mitral valve to the left ventricle, up through the aorta to the top half of the body, or through the descending aorta, bottom half of the body. The iliac arteries are going to branch into the distal limbs, down all the way to the feet, exchange at the capillaries, move back up. Same thing with the arms. If it's below the heart, it'll drop its blood in the inferior vena cava. Same thing, top above the heart, superior vena cava. Deoxygenated blood into the right atrium, tricuspid valve, right ventricle, off the top of the heart through the pulmonary semilunar valve, pulmonary arteries rather, and then the lungs, reoxygenated in the lungs and back to the pulmonary veins. Walk through this, quiz yourself on it. It's not that many steps. Make sure you know it, and please email me with any questions.